Okay, we'll take our real quick look at the calendar. Today is Thursday, March 27. So we finished up 2.9, although there's still plenty of practice problems to do. Again, as you're studying for tests and things like that, the goal is to do as much blue as you can. There's not enough time in class to do all of blue. I know that. So really spend time outside of class, especially with the ones that you don't like. I mean, it's some of these really hard multi-step word problems are difficult for many people, and that means you got to spend more time on them. You're definitely going to see them on the test. The good news is 2.9, which is the section you were just working on, is not on the test, not on this coming test. Okay, so we are going to start 4.1, and then next class is our review at the start and then exam 2. I will just point out we are not meeting this coming Tuesday. Again, this coming Tuesday is advising day. There are no day classes scheduled on Tuesday, so we will not meet. I said something wrong last class. I said evening classes were canceled too, or at least I thought they were. They aren't. Anybody have a Tuesday night class? Okay, so it doesn't affect you guys, but Tuesday night classes are on as scheduled. So we won't meet on Tuesday, but hopefully you'll come in, meet with your academic advisor and get registered for the fall semester. If you don't know who your advisor is, see me right after class and I will look it up, okay? All right, so the good news for many of you is that this section that we're about to cover here really doesn't have word problems that are anything like the ones that some of us are struggling with right now. The word problems that we'll see in here are all related to geometry, and they're all pretty straightforward, plug something into a formula. Definitely not the multi-step problems that you're spending time on now. Okay, so we'll begin with the objective, Marcy. Okay, so let's try working through some of these. This is going to seem more like, straight up algebra. Again, not a lot of word problems in the section. So x times x, we have a shorthand way to write that. How do we write that? X squared. That's x squared. And then x plus x, we can combine those terms and get 2x. And that was so much fun. Let's try subtracting. How much is x minus x? 0. They cancel, right? Completely disappear. And then finally, x divided by x is 1. Yeah, I mean, like the natural choices are 0 and 1. But if you have a fraction where the top and bottom are the same, you have a 1, 100%. Okay, so those ones generally are pretty straightforward for most folks. But then we get into the more complicated versions of those kinds of things, like in number 2, 5x times 2x. There are a lot of different wrong answers that we could put for this, and there's only one right answer. That's close. I'm going to do some shuffling around that you don't need to do, but I'll just put it here. I'm going to shuffle around this multiplication. I'm going to write the 5, then I'm going to write the 2, then I'm going to write the x, and then I'm going to write the last x. Because this is just multiplying 4 things together, right? Even though there's only one dot, there are invisible multiplication dots in between the 5 and the x and the 2 and the x. So that's just a straight multiplication of 4 things, and we know we can multiply in any order without changing it. So I'm grouping together the numbers, the 5 and the 2, multiply them and get 10. And then I've grouped together the x and the x, and what does that equal to? 2x. X times x is x squared. And I'm glad that we just heard 2x because that's a really common thing to write. You see a couple of x's, you think 2x. But it really depends on whether those x's are multiplied, like here gives you x squared, or added, which would give you that 2x. Okay, how about 5x plus 2? 7x? Can't simplify. Is it one of those things? Yeah, these are not like terms. And if you remember when we were playing with the algebra blocks, we had 5x, those were the yellow rods, the rectangles. And then we had 2 green cubes. Could you say you had 7 anythings when you were trying to add 5 of these yellow guys with 2 of these green ones? They just didn't. They just didn't go together. I mean, if you want, you can just copy it. Or if you want an abbreviation, cannot be simplified, CBS. It should. If it doesn't, it should. Yeah, that's it. How about number 3 here? 2x minus 5x. Can we push those together? Yeah, those are both x's. They get combined. So what do we have when we smush them together? Negative 3x, not negative 3x squared, just negative 3x. Okay, let's look at this next division. 2x over 10x. Okay, we're going to reduce some stuff. What happens with those x's? What did we get when we had x over x? We just had plain 1. So this x over x is 1, right? I mean, it's like a fancy way of writing 1. It's just 1. So you can cancel, just like we canceled the x's, we're going to cancel the x and the x here. X over x is 1. You can replace them both with 1s if you want to. And then 2 over 10 reduces to 1 over 5. Okay, the next one, 10 over 5x. So this one, it's kind of strange because it seems like they don't really go together, right? Like the 5x plus 2, they didn't go together, so it couldn't do anything. And the 10 and the 5x, they seem like different things, just like the 10, the 5x and the 2. Can I do anything here? What can I do? Yeah, multiplication and division are not nearly as picky as addition and subtraction. You can multiply and divide just about anything in the world. What you can't do is add and subtract anything in the world. So we can divide 10 and 5, they reduce. What does that become when it becomes a 2 on the top and a 1 on the bottom, which I won't write, but what else is still on the bottom? X. So this is the answer. It's 2 over x. Again, you can multiply and divide just about anything in the world. What you cannot do is add and subtract anything. All right, let's take a look at number 4. X times x plus x times x plus x. First, we got to think about order of operations because you don't get to just do it left to right. All the multiplications have to happen first, yes? That's what we have to do. We've got to do the x times x, which we've already seen is x squared, plus another x squared, plus x. That's a good question. Does it become x to the 4th? That's a question. Okay, Holly? Holly says possibly 2x squared. And I see 3 things there, so maybe 3 of something. Yeah. Okay, but we can see there are a lot of different answers that seem natural, that seem reasonable. There's only one right answer to this thing. This is something new for us to add x squared and x squared. Well, here's the idea. Instead of x squared up here, just picture an apple. X squared equals apple, okay? So this really says apple plus x, right? So if I said apple plus apple, what do you have? You have 2 apples, yes? So it's 2x squared. Two x squared plus x. We'll see if we can do anything further in a minute, but let's make sure we're on board with this. X squared plus x squared goes together. It's the first time, I think it's the first time we are putting those 2 things together. It's the first time we're having this opportunity. But x squared plus x squared goes together because you could trade them both for an apple. You have 1 apple plus another apple, you have 2 apples. Notice that it doesn't become x to the 4th. It's a really easy thing to think. X squared plus x squared, x to the 4th. It's reasonable. But it doesn't become apple squared or apple to the 4th. It's just you have 2 apples. You're just counting. So really the only time that power changes is when you are multiplying. Go back up to the very first example. X times x, that's pretty much the definition of what x squared is, right? That's when the power changes. But when you're adding x's, you just end up with x. And when you are, some other adding x's, yeah, over here, when you are adding or subtracting x's, you still get x. When you are adding x squareds, you still get x squared. Okay. But I said addition and subtraction is really picky. So 2x squared plus x, can we mush them together? The answer is no. The only way we can put together things is if they are both exactly the same, like apple plus apple. But if x squared is an apple, then x is an orange. And I have 2 apples and 1 orange. I don't have 3 of anything. Well, I guess I have 3 pieces of fruit. But we cannot put those together. Let's take a look at number 5. So we've got in parentheses negative 5xy, and then the whole thing is squared. And before we think about that one, let's just look at the next one to the right. It's like I could read it the same way, but without parentheses.
But it's not the same.
Yeah, that's why we're putting these here. Tyler, hold on one second. You're stealing my show. So yeah, I mean, the reason they're both here is to make sure we can distinguish, because as Tyler says, they're not the same answer. So we got to make sure we can tell them apart. So let me just look at the second one first. Negative 5xy squared. Can we mush anything? Can we do any algebra in here? No, it's just sitting there. It is what it is. It's negative 5xy squared. There's no commands for us to follow. But here, we're being told to square something complicated. So there is something for us to do. Jen? We do. And there's a little shortcut that if you take the next natural math class after this one, it's intermediate algebra. And you'll see that shortcut as a rule. Here, we're not memorizing shortcuts. We're just going to develop intuition. But yeah, you're right. The squared comes in on everybody. But here's what I recommend you do. If you see something complicated squared, just go back to basics. To square something means you multiply it by itself. Yes? That's what the command squared means. So I'm just putting 2 copies of it. Okay. And again, I'll write a step that I don't need to see, but I think it's important at this first go around. This is straight multiplication. Don't let the parentheses fool you into thinking there's more priorities here because there's parentheses. It's just 6 things all multiplied together, right? And so if we're multiplying, we can shuffle things around, and I'm going to choose to shuffle together the things that go together. So I'm going to choose to put the numbers in the front, negative 5 times negative 5. And then I'll put times x times, what's the other guy that goes with this? Before we get to that, I want to group the other x in here, and then times y, and then times y. All we're doing is shuffling around multiplication. And now that the things are grouped, I'm ready to write my final answer. What's the number? 25, that's positive. X times x is x squared. That times y, y squared. So that's our answer. You can put dots for multiplication if you want. 25 x squared y squared. Now Jen was actually onto something before. She said the squared comes in and maybe hits everybody. What do you get when you do negative 5 squared? It's 25. What do you do when you do the x squared? Well, it's just x squared, just there. And then that y also gets squared. So Jen's got a shortcut, and if you don't show me this stuff on a quiz or a test, I won't penalize you for it. But you better really know this shortcut quite well. And if this is the first time you're seeing this kind of problem, I would say don't go for any shortcuts. First principles. Something is squared, you write it twice. Questions on this one? Is it what? Simplified? Oh, yeah, this one, you might get some debate amongst math folks. Like, what does it really mean to simplify? This is what I want you to do something here. Okay, good question. All right, let's do number 6 together and then group work on the next page. All right, have we seen this word in this class? I think we have. Oh, yeah. Yeah. Yeah, this one cannot be simplified. There's nothing to do. Okay, I think that we've seen this word in this class before, right? Evaluate basically just means plug in. So we are trying to evaluate this complicated looking thing here. I'll highlight it in yellow. So that guy, when x is equal to negative 5. So all of these x's become negative 5. So I'm going to write that thing down. But instead of every x, I'm going to put parentheses. Instead of every x, I'm putting blank parentheses. So I copied that whole thing. It's probably easier to follow the directions instead of looking up and copying. You're rewriting that whole thing in yellow, but every x becomes empty parentheses to be filled in. Everybody understand the relationship between the yellow thing and the green thing right now? Questions? Nicole, are you with us on that? Every x just became a blank set of parentheses to be filled in. Okay, and what are we told x is supposed to equal in this one? -5. So all of those empty parentheses become -5s. Just -5. Okay, now we've got arithmetic to do, and it's not the easiest arithmetic problem in the world, but let's try it. Equals, okay, -5 squared. Is it 25 or is it -25?
It would be 25.
Yeah, it's -5 times -5. It's positive 25. Plus, okay, we have to do what's in the big parentheses first. -5 plus 3 is -2. And that gets squared, right? -5 plus 3 is the -2. Yeah. And then over here, minus 5 is the same as +5. That's 25 plus 4 plus 5. Okay, so questions on evaluate? Is that all right? I'll leave this up here for a moment. So move on to the group work on the next page. We're going to come back together for like the last 5 minutes of class to do one more problem together. Okay, so I think that some folks are getting close to finishing these and some still have work to do, which is okay. I will just share something that one person said. These all look the same. Okay, and so that's why we're putting them up here all together with the same numbers, but surprisingly different answers for just about all of them. And part of what you're after here is training your brain to kind of recognize these new patterns, recognizing the order of operations and what do we have to do first and what has to wait, and do negative signs come down? Can we combine? All of these questions have to be answered to get to the right answer. So let's move on to the next page and we'll do this, this group problem together. We want answers.
Like 1 minute.
What are we doing here? Is it here?
Yeah.
Are these the answers? All right, so on the next page, just a quick reminder, all of those answers are available on Moodle. And in fact, it used to be that Moodle was programmed so that the answers to all the blue problems would be released like a few hours or maybe a day after we had the class. But I just recently put all the answers to the rest of the blue packet up. So you have the answers to the entirety of this packet already available on Moodle in PDF form. So check them out. You can always check your work. Okay. Number 5 says we're going to solve this equation, f equals k times little m times capital M over d squared. So that equation is quite a bit more complicated than any we've seen this semester. I will say this equation is important in physics. It has to do with the force, that's the F, between two bodies. So like, it turns out that any two things that have mass exert a force on each other. So for example, Megan and I are exerting a force on each other. She's pulling me a little bit that way. I'm pulling her a little bit this way. But our masses are so tiny compared to the real force that we are all feeling getting pulled to the earth that there's like no actual impact, right? But in theory, every two objects exert a force on each other. And it turns out this is the formula you use to figure out what that force is. There's some magical constant K. It's just a number. And then you multiply the two masses of the objects. Those are the m's. And then you divide by d squared, the distance between the folks squared. Okay, so we're going to solve this equation for m. So I'm just going to circle that m real quick. We'll do this real fast. Okay, M is has a lot of stuff nearby that needs to move out of the way. So we got to move all the letters out of the way of that little m. So first thing I see is that all of this stuff on top is being divided by d squared. What's the opposite of dividing by d squared? Multiplying. So I'm going to write my equation again. We're going to go like a minute over today, guys. I apologize. It's your fault. You asked for those answers in the blue. Okay, so we are multiplying both sides by d squared because that's going to get rid of the d squared on the bottom. And we're just going to do the whole thing in one shot, actually. Again, I'll circle the little m, which is what I'm focused on. There's also a times k and a times capital M nearby. What's the opposite of multiplying something by k and m? Is dividing. So we're going to do that to both sides. Divide both sides by k and capital M. Divide both sides by k and capital M. The left-hand side is just a big old mess. I'm just going to copy it. D squared over k times m times f. But on the right-hand side, there are fireworks. What happens with the d squared? They cancel. That's why we put the d squared in blue over there. What happens with the k's? They cancel. That's why we put the k there. What happens with the capital M's? They cancel. So what do we have on the right-hand side after all that? Just little m. And that's what it means to solve a crazy, complicated equation for a single letter. Yeah. Okay. So we will see you guys on Thursday. Have a good weekend.